So this is another case of a hexagon being the true shape. So let's see the exercise. A square prism of base 30 mm side stands vertical. It is cut by a section plane in such a way that the true shape of the cut section is a hexagon having two opposite sides 30 mm long and the remaining four sides 40 mm long. Determine the height of the prism, inclination of the section plane, and draw the front view, top view, and the true shape of the section. This is again a square prism. It is not a cube, but here also we want a hexagon as the true shape. In this case, in this particular hexagon, the condition is that two opposite sides are of 30 mm long, and the remaining four sides are of 40 mm long. That is the only condition that is given. So in this case, that as in the previous case, as in the case of the cube, we know that in order to get a hexagon from a square prism or from a cube, we have to cut all the 6 planes. So in the top view, it should be the square prism or the cube should be placed in such a way that all the vertical edges are equally inclined to the VP. So here also the same case is there. So first the XY line, then the square prism in the top view. We doesn't know the height of the square prism. Then how to determine the height of the square prism? That also we have to see here. So the XY line, the top view of the square prism, then A dash, A1, B2, C3, D4 are the edges. Then first what we do is we do the sectioned surface in the top view. First we draw the sectioned surface in the top view, and then from there we go on constructing the thing. So in order to say that, it is said that the true shape of the section is two sides are of 30 mm. So obviously when we cut to a square prism, two equal sides are the two equal sides. There are two equal sides which are of the opposite base as well as the top face. They will be the squares, and the all other four faces will be the rectangular faces. So obviously in the hexagonal condition, it is said that as the property of the hexagon, it is said that two opposite faces are of two opposite edges are of 30 mm edge, and the other four edges are of 40 mm edge, 40 mm length. So obviously this 40 mm length will be the edges generated by cutting the vertical faces, the longer faces, and the two 30 mm edges will be the edges generated by sectioning the top face as well as the bottom. So we know that the 30 mm edge will be in the top as well as the bottom. So in the top view, it will be seen, it can be seen in the top view, only the two edges. These two edges will be seen as the 30 mm edges itself in the top view, because this 30 mm edge is generated by intersecting the section plane with the top face as well as the bottom base. Since these two are parallel to the HP in the top view, these two lines should be parallel to the HP and the true length should be visible in the top view. That is the condition. So we mark the 30 mm on both the sides. So that in order to mark the 30 mm, you cannot take any 30 mm. It should be symmetrical. That 30 mm should be symmetrical. That is 15 mm to the main diagonal, above the main diagonal, and 15 mm below the main diagonal. For that one, what we do is we mark the main diagonal. This is the main diagonal, and 15 mm above as well as 15 mm below, we draw two lines. Now the distance between these two lines will be 30 mm. Now this is one edge which has a length of 30 millimeter, and this is the second edge which has a length of 30 millimeter, and these two lines, these four lines actually, this will complete the hexagon in the top view. The hexagonal shape in the top view will be completed like this. Now all the six edges are marked: P, Q, R, S, T, and U. Now, first what we do is we mark the point 1 dash, then the base points are marked in the front view. Now the base points are marked in the front view: 1 dash, 3 dash, then 2 dash and 4 dash, then P and Q. Now we know that P and Q are in this point, at this point. We know that the points T and U will be somewhere in this line. We doesn't know where it is because the height of the prism is unknown to us. The height of the prism is still unknown to us. We doesn't know the height of the prism. That we have to find out. But we know that T and U, the points T and U will be somewhere in this line. Now what we do is that we draw the line, this R and D, sorry, not R and D, R and S. The line, the projector through R and S is also drawn. P dash, Q dash is marked. We cannot mark the R dash and S dash because we doesn't know the height of the prism. So what we does is, this is the catch point here. We draw a horizontal line through R. We draw a horizontal line through R, then rotate the length P and R, or the with the R as center and RP as radius. We draw an arc to here. We draw an arc to here. This is what we are actually doing is we are finding out the true length of P and R. We know that the true length of PR is 40 millimeter. That we know. The true length of PR is 40 millimeter. That we know. So in the front view, we try to make that 40 millimeter. So PR is drawn, and this new point is P1, and from P1 we find out P1 dash. Now we know that P1 dash R1 dash should be having a length of 40 millimeter. P1 dash R dash should be having a 40 millimeter length, and R dash will be lying in this line. R dash will be lying in this vertical line. So from P1 dash with a radius equal to 40 millimeter, we draw an arc on this projector through R dash. Projector through R, so with a radius, and then this point is R dash. Now what we do is we join this point P dash, Q dash and R dash, P dash, Q dash and R dash, and we extend the line such that that line intersects the projector through T and U, and that particular point, this point will be T and U. So this is our section 3. This is T and U, and the height of the prism is the distance from here. The height of the prism should be the prism should end here. So the prism should be ending here. See here, the prism should be ending at the point P dash U dash, A dash, B dash, P dash, and C dash are marked. Now the height of the prism is this distance. This distance is the height of the prism. This is the height of the prism. Now R dash S dash is marked. Now you can draw the front view also. I mean the true shape of the section also. And once you completed the true shape, you can find out that it is having a length of 20 in these two edges, that is PQ and TU. It will be, the length will be 30 millimeter each, and PR, RT, QS and SU will be having 40 millimeter length. So this is how it is being drawn. I'll show you how to draw it once more. So first we draw the rectangular prism, the square prism in the top view. Then mark the points. Then the main diagonal is drawn 15 millimeter above and 15 millimeter below the main diagonal. Two lines are drawn. This for 30 millimeter, and the two edges which has the lower length is drawn. Then this is drawn. Sorry. Then P, Q, R, S, T, U are marked. Then the front view. In the front view, the points on the base edge is marked. The base faces is marked. And the projectors through TU and RS are drawn. P dash Q dash is marked. Then a horizontal line through R is drawn. Then P is rotated to this particular horizontal line. Then from P1, the projector is drawn in order to find out the P1 dash, and from P1 dash 40 millimeter radius line is cut through the locus of, through the projector of R and S. Then P dash Q dash is marked with the R dash, and the point of intersection of this line, this particular line with the projector through T and U, will be marked as T dash and U dash. This is, and through T dash and U dash, the top face of the square prism is also drawn. Then, as usual, our true shape is also cut. The angle of inclination is the inclination of this section plane with the horizontal, this angle. The angle of inclination of the horizontal, the section plane with the horizontal is theta.